Okay, let's say you have there's a thing called double thing s equals goodness. Alright, what do we do here? I'm making this video sort of partly out of frustration because I've seen like multiple people who know what they're talking about. Like you get these C++ guru motherfuckers who are all like consultants and academics, and they've popularized this method of visiting a variant, which makes no fucking sense at all. And well, it makes sense, but it's just really stupid. Like I have to conclude that anybody like suggesting this as a method of visiting a variant must just not, they've never used it in any actual code, because if you use it in actual code you should like pretty quickly see why it's so stupid. So let me see if I can remember from memory. It's something like you create this like special type called visitor or something like that, and there we go, Copilot knows what I'm doing. So well, let me use it first of all, and then I can explain what's happening. So you go standard visit. Oh, Copilot knows exactly what I'm doing here, I think. Yeah. So this is how you do it. It's so popularized that Copilot just automatically filled it in for me. And it's really stupid. So what's happening here is we're doing this thing called aggregate initialization. So let's say you have a struct called S, which has, for example, an I and a double and a string like that. You can initialize an S using aggregate initialization, which is where you just open curly brackets and then you put the values in, and you can initialize it like that. So exactly the same thing is happening with this thing. It's like has a variable number of template arguments, and we're inheriting from those template arguments here. And then we're saying for each of those things that we're inheriting from, I want to expose the call operator. And so we're using aggregate initialization to initialize this visitor thing with 3 lambdas. And these lambdas have different types because every lambda has a unique type. So we're initializing it first of all with a lambda that takes an int and does something with it, and then with a lambda that takes a double, and then with the lambda that takes a string. And each of these lambda objects that the compiler creates behind the scene has a call operator, and we're inheriting from each of these lambdas within this visitor thing, and then we're exposing the call operator. So that's the magic that's happening here. So then when we call visitor with this, we call visit with this visitor thing, and it's basically creating an overload set. Like for example, another way of doing this would be if you were to do it manually, you would just have the call operators written in here. Again, Copilot can fill it in for me, and then you would just call it like this. But instead we're doing it inline because then you don't have to create a separate type every time you want to do this. You can just do it inline. You could just create this generic type which works for anything, and do it inline like this. And in slideware, like not real code, like the code that we've written here, this looks quite neat and readable and looks okay, and you can sort of look at it and understand what's happening. But again, this is slideware. This is not real code. So in real code, these handler lambda things are not going to be one-liners. Eventually, they're going to, like, inevitably, even if they're one-liners to begin with, inevitably they're going to grow into larger functions. So, and eventually what you end up with, as your code base grows and you keep making changes and these functions get bigger, you end up with this syntax slop, where if you like look away from your computer monitor for a second and then look back, your eyes are going to land somewhere, and they might land somewhere somewhere unfortunate, like here, like this close curly bracket, comma, and then open square bracket, and you're like, your brain is like, what is this code? Like, what is happening? Because this does not look like normal C++ code. And so you have to like scan upwards and see, okay, so this is a lambda, and then you're like, oh, okay, we're doing the stupid thing where we're visiting a variant by using this stupid overload construct thing, which you use aggregate initialization to pass it some lambdas, and so that's why. And so, and if it gets like really long, then anyway, it just gets difficult to scan the code, in my opinion. And so what do we do when we have lots of lines of code? Obviously, we can just take all this code and put it into a function, right? So we would put a function, we'd say something like, so now you look at this, and you realize that everything that we've done here, all of this, like this thing where we're constructing these lambdas, and we have this weird thing, it's all just pointless boilerplate now. Why don't we just call those functions that we wrote? Like, we have the logic for each of these things here. All we want to do is call the right function, and we're doing all this like stupid boilerplate. And of course, we might have a bunch of types here. It might be 100. And it's all just boilerplate. There's no reason to write any of this, because what you can do is just turn this into an overload set. Get rid of that stupid visitor thing. There's no reason for it. And just use a generic lambda like this. There we go, Copilot's filled it in for me. That's it, that's all you need to do. And again, if you start with that other, like the stupid way of doing it, inevitably you're going to be like breaking the logic out into separate functions anyway. So you're going to end up with this anyway, these separate functions for each of the things that you want to handle, most likely in a real code base, if it's not just slideware. Also, a convention that I use is to actually keep this underscore at the end of these, at the end of the overload set. Because if you remove the underscore and remove one of these overloads, for example, often what I have is I will have one function, like in this case, for example, I have a function called print, which actually takes the variant type and then calls visit, where it forwards it onto the overload set. If you forget one of the handlers here, then this will actually compile, because it's just going to stack overflow, because it's going to see itself and it's just going to call itself over and over again. It's just going to do this because whatever type inside this lambda is just going to convert back to this variant type. So, but if you keep these underscores at the end, that's what I do, then it will flag it up as a compile error. So. Alright, that's my rant about visiting a variant.